application and innovation. So you will see a lot of innovative.
To the students, because in the harbor we have, I think, 6,000 jobs available. It's equated because of soldiers. And these are examples of the drones. They are experts in drones, not making themselves, but doing all kinds of experiments with it. So they have a few there. And sometimes they have a very small one, I don't know if I see it here. One in a cage, so it can go up to the ground.
The water comes from the tap, or it is pure?
Demi water, right? I said.
Okay.
So it's not tap water.
Okay.
Okay. And like I said, this is a reversible PEM cell, that's what they call. So we use it first to generate hydrogen, and then we can also use it to make the, how do you say, to make the car run. Yes. Thank you. Oops. And we could have flown it directly under the sun. And what's important about the solar panel, I think you guys already know a little bit, the shading and how it stands in degrees, so it has to be like the optimal. Let me see if you can see it direct. So if you see this one, it's already starting to get up. So you can say the process is already going actually. And what I said, normally we have to wait like 10 to 15 minutes to see literally a big air bubble. But yeah, you can see it already going. So yeah, we're creating hydrogen right now. And I think this one is already a little small bubble. But what I said, I did it real quick, so I didn't do it precisely. Water into your oxygen and your hydrogen. So that is the electrolysis.
Okay, but now directly we didn't put any energy here. Electricity.
Electric.
Okay, but not in the water.
No, in the water comes. Here is the water. The water is the same. the level of the water is up till here. So it will
Inside
also
of this
inside of
box.
the cell.
Ah, okay.
In order to cell,
That's the chemical processing.
Okay. Okay.
There's a plus.
Okay. Hydrogen comes from here to the
Yeah.
tube, right?
Yeah.
Not from here.
No.
From
no,
here.
no.
Okay. From
This
here. This
here is
Inside.
producing the
Okay,
oxygen.
separate.
Separate
hydrogen and water. Okay.
2 oxygen and 1 hydrogen.
Okay.
And maybe they're also both on another ship. How can you make them work together, or like in space? When you move the robot arm, then the space arm is also moving. So he's trying to do all kind of things that two robot arms work together on something. Where the robot arm is not on a stable platform, but on a experiment with ships. There's a big wave maker on the other side. He can make big waves, and then you can use all kinds of experiments with ships, and also with the underwater drones. We have a few of them, and now there's a This is 3D printing. One of the experiments was to make a very big thing from metal, like screws from a ship, and to have it without with high quality. The idea is when you can make that in 2 days, then you don't need to carry the spare parts anymore. So now you have everywhere in the world you ship. Brakes, wherever in India, you want to repair it, you need to bring another one there, but you can also 3D print it. And they have all kind of rope arms there. Welding, they are welding that thing. And here you see the examples. Hold it. What they tried is, you see the layers of the 3D printing. What you want is that there is no air inside. So it is very solid. Yeah. So they opened it to see. You can hand it. And it's just a wire coming out for welding, and that does it in all kind of layers. Yeah. because they're all existing already. So what they do is to use the use of it. The new students that they learn how to work with it. This is the vocational education, and I'm working for the university. This is the school part of it, with all the labs and everything. Everything, not the standard cars, but the new developments. So they try to make a car that can go as far as possible on 1 liter of gasoline. Or they try to make a car with the hydrogen engine that it can go very far. Or with batteries. They're trying to invent all kinds of new things which we use in the car industry. And there are students who are studying that, so they do a lot of experiments there. I am not of course here, so.
Mr. Van Vechel is running this proto lab, and I asked him yesterday, is it a good idea to invite the Turkish people here? And he said, yeah, bring them. So he can tell you what it's possible for today.
Yeah, okay. So I would like to. Hello. All right. Sorry. Yeah. Hi. Justus. I think, if I'm correct, you've had a tour of basically the entire facility by now. So what are the workshops, of which is the RDM Programme? One of the workshops here that's mainly focused on digital making, digital production, digital techniques. By which I mean we do things with 3D printing here, with laser cutting, and we're working with light electronics such as Arduino, Raspberry Pi. Although we are right now currently also upscaling our battery power and our hydrogen electricity generation facilities. I understood that you have an electrical engineering background. Okay. I thought it would be nice that you were going to be here for around an hour to give you a small introduction about like 3D printing and laser cutting. That might actually be a bit fun to do. Yeah.
All are working for the same project?
No, these are all from different. Like we have a lot of automotive engineering. There's industrial design engineering. We have regular engineering. Sometimes chemical engineering come by. Sometimes even non-engineering related disciplines. Imagine that. No, architecture, civil engineering as well. They basically come here. I think one of the big strengths of these workshops is that they're not under one specific discipline. Hard and got so far, but in the end it didn't really matter. It never really worked properly. We started off with Ultimakers. I am very much opposed to the usage of Ultimakers since they are just fast and suck. Yeah, then we got like so I actually upgraded it to run on Clipper with a Raspberry Pi at some time. Yeah, basically also also power our fuel cells. We have a couple of fuel cells, they also need maintenance run, so every 2 weeks they just need to run a certain amount of time. What this does is, it's not finished yet. This is the power supply. This will simulate the behavior of a wind turbine that we have almost installed outside. So we will collect data from there, and then we will program it from here. And this, you know what, this is also fun to show. We have this, yeah, exactly. You can take it and have a look if you want to. We have this here specifically because students usually come in here with like, I need to have a deadline, I need to finish my year project vehicle. So in the second year there are a couple of automotive engineering groups. 4 will have to make a internal combustion engine optimized by a certain motor control system, and 4 will be working with a full electric system. So, and they are basically coming here to test and verify if the motor works, how it works, how they can tune it, the motor controller is suitable, and how fast it can actually go. So basically it's all happening here. Some of them like to go a bit in depth. I want to be a bit careful, but here you can actually see that, you know, it's just very simple. It's actually just here. It was supposed to go on the pole and then be done, but it went kaput. So we got like a couple of backup parts. Yeah, as you can see, it really looks a lot like the motor. Starting to work on something like this as well. This is the actual robot arm of an open source robot. So I don't know if I can open it up. This is all 3D printed, by the way. Let's see if I'm a bit careful. There are some servos in there.
Yeah.
Thing is, I don't actually know how to open this one.
We shouldn't force.
Yeah, we should not force.
Oh, high torque servos.
Yeah. Basically one for every finger. There's going to be 5 servos in here. They're going to be attached. 1 string to close it up, 1 to open the fingers up, 1 to close them down, 1 to open them up, and then we go from there. And we plan to run it all with a
P0.
Yeah,
P0?
with a 5 pico and a level shifter because it's 3.3 volts. But so far it's been really fun. Please don't show my colleague.
Automotive engineers. This is why they do their projects. So they come here in the first grade, and then we teach them about engines and how a car is built and what are the systems that are integrated into a car. And then they make their own vehicle for a complex problem which they get from a company. So the company tells them they have a problem with an idea or something, and then they make the vehicle. Projects for the 3rd and the 4th grade that have like a Formula student vehicle, just a study model. We're not actually competing with Formula student, but it's a study model. So they start with which ideas do you have for an engine or for a body, aerodynamics and that sort of stuff.